All right, here was your try. Let's see how you did. The first thing I want you to realize is that this top one is a double. It's separated with a subtraction, so this is a double. Over here, it's subtracted, so this is a double. Down here, it's separated with a subtraction, so this is a double. But this booger down here is a triple because it's separated with two signs, so this is a triple. The other thing is you can only reduce a double with a double if it's identical. So there's a lot of factoring we've got to do here. So the whole genre of this is factor me first. We're going to factor the tops and the bottoms that we can and get this in the correct manner. The first thing I want to do is take a look at k minus 7. Now, it doesn't have a GCF. There's no difference with two perfect squares. So k minus 7 just stays the way it is. On the bottom, we've got a trinomial, which means we're in magic X world. We've got a times c on top, which is negative 12. B on the bottom, which is negative 1. And we want factors of 12 that make 1. So that would be 4 and 3. And because I need to get a negative 1, I have to put the negative with the 4. And the 3 becomes positive. That's how you get negative 1 when you're adding them. So when I go to factor, don't forget the x here. Oops, it's not even an x, it's a k. That we have a k minus 4 and a k plus 3. So that's the bottom of this one. Now we're going to move this way. And this top is two terms, but it has a GCF. Notice that we can divide out a 7 and a k. So we're going to put 7k here, one parenthesis. And when I take 7k out, that leaves me with a k minus, and 28 divided by 7 is 4. The k already comes out, so that's what that factor looks like. On the bottom, there's a GCF of 8k. So you're going to divide that by 8k. You're going to get k minus, and 56 divided by 8 is 7. So we're all factored. We're going to pause the game right here, and we're going to do some exclusions now that we're all factored, and every single denominator has a variable in it. So that means we're going to have 4 exclusions. 1, 2, 3, 4. Let's get started. Over here on the side, exclusions. K minus 4 equals 0. I've got k plus 3 equals 0. I've got 8k equals 0, and I have k minus 7 equals 0. All 4 of these will generate an exclusion that we cannot have in our problem while we're working on it. Add 4, so k can't be 4. Subtract 3, k can't be negative 3. Divide by 8, k can't be 0. And add 7. K can't be 7. These are our exclusions. When we solve for that variable, those are the ones that can't happen. Because if we put any of those numbers in anywhere at one place, we're going to get a division by 0, which makes it undefined. Okay? So now that we're done with our exclusions, we can go back and start reducing. Remember that we can only reduce doubles with doubles if they're top to bottom and identical. And check out what we got. We got a k minus 4 and a k minus 4. They're identical. We've got k minus 7 and k minus 7. They're identical. And I think that's it for the doubles. There's no k plus 3 on the top anywhere, so that's kind of stay put. I do have a single term with a k and a single term with a k. And what I need you to know is that these are really small multipliers, which means that this k and this k can reduce as well, which means that we are done reducing. We have done a great job. We've got 1 times 7 times 1 times 1. So we've got a 7 on the top. And we've got k plus 3 in parentheses times 1 times 8 times 1 times 1. So I'm going to put the 8 on the outside of the parentheses and then k plus 3 on the inside. And this is my answer. And those are my exclusions. Please contact your teacher if you have questions about this. And we've got one more for you to try, but if you don't need it, just skip it and move on.